after dev, there's a very important stage, and it's typically QA. Sometimes it's a couple of environments, but really you've got to get through QA. Now, you and I both come from development backgrounds, so we know about test-driven development. We know about behavior-driven development. Um, we know that it's great when you use it, but it's hard to use and enforce. You have to be very methodical about it. You really have to have a very good dev managers and things like that. Because a lot of times you're a developer, you just start cranking along because you got to get stuff out the door. And unfortunately, I did this in my career, is I found that if I spent the time up front writing tests and letting them fail, that I spent less time fixing stuff later on. I actually got more out the door, even though it felt a little weird at first. But at the end of the day, right, we've got QA, going back to our main topic here. What that really is, and everybody knows this, is that whatever's being released should do what it expects. In other words, 2 plus 2 should not equal 5, it should equal 4, but also that when I enter in 2 plus 2, that the plus sign actually works, right? If it's a calculator, whatever it is. So I got to make sure that whatever's delivering works and works as it is intended to. And I think that's really, really important because we become so digital in terms of how we interact with things. That user experience is crucial, right? Nowadays, people will make a choice on a bank, for instance. They don't go into a bank anymore. They will make a choice on the bank because of the website and if they have a nice app. Right? It's that user experience, and you got to keep up with it because if you're not innovating, somebody else will. So the question is that, right, we got QA in there. That's a major step, and it seems to be that that's kind of a key thing. So what are some of from what you've seen and in the study, what are some of the typical challenges seen during the QA as it relates to the deployment? Because again, that step seems to take quite a bit when we look at the overall release process in the SDLC. So again, what do you see in the QA process? What are the struggles? What are the things that hold teams back from being able to have that automation and to deploy faster when we look at that QA stage?
Yeah, I think there's been a lot, and through my career and in the report, especially, like, there's been a lot more rigor applied to software quality, like throughout the SDLC. And so a lot of times people are getting kind of hit early on. There's this whole mantra of shifting left, like poor engineer, everything will be shifted left upon him or her at some point, right? And so a lot of, if you take a look at very modern quality engineering QE organizations, like they're basically trying to mimic production as quickly as possible in some shape or form for the engineer before going to production, right? And so a lot of times kind of ratifying, like, it's just not just a test suite. You're getting barraged with a bunch of application infrastructure level tests, infrastructure tests, even those functional tests. Like those are the tests that people don't really think about. Like, oh yeah, as an engineer, we'll pass our functional test, sure. But what about the infrastructure it runs on, right? Like, you're deploying to Kubernetes. You didn't request enough resources, so your app will crash, right? Like stuff like a very basic case like that. But that type of rigor is getting introduced very early on into the SDLC, and that's kind of mimicking the QE and QA cycles that's going on. One kind of like taking that question in two separate parts. One, what we've seen, there's a lot more emphasis on getting the feature out the door, but with like, hey, as a development manager, I was bonused on feature delivery, right? Like my MBO was prudent to me shipping something, right? And so it's like, when has a developer shipped something? When it hit QA or when it hit prod? And there's two very different organizations. Because if they have to hit prod, like at some point there's onus on the engineer or some set of engineers to make sure that the release is successful. And so you're even starting to test like the deployment in QA, right? Which is funny to say that, like, hey, you know what? If we have a 6 or a 7 node, odd number, make it easy because of consensus. We have a 7 node cluster in production. Well, we have a 3 node cluster in QA or QE. So prove it to me that it's successfully being able to deploy, which is hard, right? Like you have to prove that. And so not only that you have to get your functional tests across, you have to also, you're hit with a barrage of deployment level tests. Like, you know what, can we deploy in place, right? So a lot of times a majority of people, you're not deploying an application for the first time. It's very rare that, like, I always envision a ship getting sailed and you hit it with a ball of, champagne and it floats into the water. Like, very rarely do you experience that, because most of the time you're going between, sub or minor or major versions of software. Like, you're coming in during the middle, right? And so that ship is already sailing. You need to make a repair or add an engine or something. And so they need to test that type of confidence early on. Going back to, like, hey, like, where we see a lot of people struggle is like, hey, can you prove it to me that you can deploy successfully in QA? And they're like, you know what, it's that painful. We're bringing up production level pain already, because we have to figure that out before we get to the higher environments. Because you're not going to figure out a rollback plan in production, right? You're not going to figure out, unless like something else to introduce, you didn't see it, but you need to validate the safety mechanisms that you have. And I think that's where it gets more challenging. Like, that's more of a principal engineering job, right? To start doing that as a developer. Yeah, I wrote a function, it passed like my unit test and code coverage, sure. But as you start getting into the whole team, it's confidence in will it actually be installed and deployed. And that's where we see a lot of people like kind of hit the brakes. Like, yeah, like our production level releases, kind of modern infrastructure, if you're leveraging something like Kubernetes or another orchestrator, that you're able to mimic production in a smaller set or the same set in a lower environment. So that safety rigor is going into it. And that's where we see a lot of time people spending in, they're basically doing a deployment for their changes. Yeah.
But I think that brings up a good point, right? Which is, we go back to this templatization of things. Now, let's be honest. When we're thinking of microservices and stuff like that, we're thinking cloud native. So we're in some sort of Kubernetes-based environment. And for those that are watching and are familiar with that, it's very easy to scale up and down because compared to traditional infrastructure. So obviously that means that you're going to have different deployment and different strategies there. But I think you bring up something very, very key. It's one thing to test your application. I'm going to go back to my simple calculator, 2 + 2 = 4. Great. But I think as part of that is what we typically have done further right, penetration testing, load testing, things like that, but then also testing the deployment, which is, do I need 1 instances? Do I need 2 instances? Do I need 8 instances? What do I need? But then also, if you start to get into things like auto scale, am I putting that load on and making sure that my setup is auto scaling, because I don't want to hit an issue and the app crash and then try to scale. I want to scale before I ever hit that issue. And again, as we shift left, that means there's more onus on the developer, because they're not just writing code, right? They're basically saying, how do I make sure my application or my service runs at whatever scale, whatever the requirements are, whatever the business needs are. And the only way that we've been able to do that successfully working with customers is through something like Harness, because you're templatizing things and you're basically getting organizations to think your deployment in every environment is actually the same, right? Your application, your service. Now, you might have a different set of approvals that you have to do as you move through it, but what you do as that deployment shouldn't change. And usually they're like, oh, wait a minute, because now they like that light bulb goes off and they're like, you're right, it shouldn't change. And that's how we get back to, how do you test your deployment? Because the only way to test a deployment is we have something that's repeatable, right? And because again, as we talked about a moment ago, is I don't want to be testing my production deployment and how I'm going to do that on a production release window.
Yep.
Because my app might be great, but if my release process fails, well, now I'm probably lengthening the time it takes to release something, and probably a lot of people get a phone call. If you've been like me, where you started deployment on Friday at 5, and you and a bunch of other people are all in a conference room or on the phone through the weekend, just waiting, right? Everybody's on the phone waiting just in case they're needed. And that takes up a lot of time.
Yeah, it takes up a lot of cycles. And like, this one more point to that, like to the testing, right? Like, testing methodologies change all the time. Like, there's new ways to test. There's more novel ways to test. Things like chaos engineering, like that wasn't in people's vocabulary, 5 years ago, but it's becoming more and more, important. One of the last things that we kind of like want to leave with around testing it's also rule sets change, right? So the level of rigor you apply to somebody changes. Like a very good example of this is open source security testing. So I'll give you an example. Like one of the things that organizations, and this is why having a tool like Harness or like having a robust pipeline is important, because even though there's conflictivity between stage to stage, so between dev, QA, UAT, prod, your rule sets of how much like what you vote as a passing score will change. A good example again is open source security. So for example, in your development environment, usually forward-thinking organizations will say, you know what, we want to give developers lateral freedom to innovate. So if we find an infringing package, like this is like new way of thinking. Like 5 years ago, we wouldn't be having this conversation today. It's commonplace that organizations will talk about this. We want to give developers like lateral freedom. So if we were to flag something as malicious or something as suspicious, we don't want to fail the build because of that. Like they have a good reason of using it, and then they can justify it in other environments, so then we can pass that stuff along. Versus, oh, you know what, the build will never succeed because they used something that wasn't approved. Well, there's a reason why they took it, right? Either they know or don't know. So it's an educational tool, and also it's like you have to innovate, so you're justifying a change. But there's lots of testing methodologies that actually incorporate that, right? So I call it the tightening the rope type of model. It's, you know, how do you model in new testing methodology? How do you model in differences in rule sets? And this is why having a robust pipeline is so important, because if you have to build this, like not only are we making a workflow, we're making some sort of decision or rules engine now. Like that 66 hours to do it practically is looking like a 3 to 4 month sprint, right? Like this is what it's starting to look like. And so like those are things that people would expect like to be able to have these capabilities. And that's exactly what Harness does. Like you can change around the threshold. It's not a big deal. You want to add, you know, an open source security scan, go for it. You know, that's not very difficult. You want to introduce chaos engineering. Actually, I was just doing something with a chaos engineering vendor, you know, proving a few things out. Like it's not hard to do that by convention. So yeah.